Ever wondered why when you push something, it moves? It's because you're applying force to it. And today, we're going to learn some of the rules about forces. This police car is being pulled on in two directions, one east and one west. When pulled on in both of these directions, the forces counteract each other, leaving the police car motionless. This can be represented by this force vector diagram, and also this free body diagram. If we were to arrange some values in a table, it would look something like this. In this example, we are using three forces, two of which are being pulled in an easterly direction, one of which is being pulled in a westerly direction. For the police car to stay stationary, both of the forces being pulled in an easterly direction must total the single force being pulled in a westerly direction. This can be shown by this force vector diagram and also this free body diagram. If we were to arrange the values in a table, it would look like this. Both of these first two examples can be calculated using the formula force total equals force 1 plus force 2 plus force 3, etc. In this example, Eric is pulling the police car with a force that is at an angle, shown like this in a diagram. Here we have made a table showing how 2 newtons of force at different angles will produce different amounts of forward force. To calculate the amount of force that would be converted to forward force, we can use this formula. The force multiplied by the cos of the angle. In this example, the police car is being pulled with two forces in different directions, but as you can see, it follows a central path between the two forces. This can be represented by this force vector diagram and this free body diagram. However, if Eric pulls with more force on his side, the police car will curve, like this. In this example, we have 4 forces acting on our police car, one in each direction, north, south, east, and west. If they are all pulling with the same level of force, the police car will, of course, stay stationary, much like in our first example. This can be shown using this force vector diagram and also this free body diagram. This example is also calculating using the first formula, force total equals force 1 plus force 2 plus force 3, etc.
There's one more force we haven't touched on, and that's the force of gravity, and it can be represented like this.